Good morning, dear student, and welcome to this 25th edition of our Numerical Method 2 class. As I mentioned a while ago, I had problem to connect, connection problem. Launching the Microsoft Teams application was difficult because of the software updates of the computer. So some software were not responding, there was delay here and there. But thank God we are there. Okay, so what did we do last time? Last time we derived, but that was the previous, the second last class. We derived the composite Simpson's rule. And we recall that rule 2 days ago. That was on Wednesday. And we solve a particular problem. So we apply that to the function f of x equal to 2 plus sine 2 square root of x. And our interval AB, interval of or limit of integration was 1, 6. So that's what we use, and we apply the Simpson rule, the composite Simpson rule to this function. We found the solution, and we went an extra mile. Some of you disappear, others stayed, like Kashopi. I remember she was there. You two, you were there. Not quite sure. Anyway, some of you were there, others disappear, of course, because you had to attend other classes. I don't blame you for that. So we went an extra mile where we coded that algorithm. We coded it using the Python programming language, which is the easiest, or let's say one of the easiest programming language on planet Earth. Maybe if you go to another planet, maybe. But here on this planet, where we are currently, we human beings, it's one of the easiest. So I encourage you to learn that language, because if you don't know how to use Python, you'll be like illiterate, right? Particularly if you say that you are doing mathematics. Some of you will graduate. I have a BSc in mathematics. Do you know Python? Yes, I know Python. Can you program this? Please, I'm coming tomorrow. You run away. So please, don't be that type of student. When they ask you a question you don't know, instead of saying, I'm sorry, I don't know. Yes, you're right. Okay, let me see. Okay, wait for me, man. You disappear. Okay. So that's what we did. I think I should start from there because some of you were not there, right? And I know that you people, some of you, maybe not all of you, are still struggling with programming. So let me go there, so that some of you will not curse me in your heart. I want you to bless me in your heart, not curse me. Okay. So let me go there. Let me launch Anaconda. Okay, so please, I advise you to download Anaconda for those of you who don't have Anaconda, and to use Jupyter Notebook because that one is really so simple to use compared to Spider. If you have to use Spider, you tap it, and then you press it to run. Whereas with Jupyter Notebook, it's just a browser. You have a web browser because all of you know how to use internet. It's a web browser. You just go there. There are cells. You enter your code in one cell and you press the enter key. Of course, Control Enter. It runs the code for you. It's wonderful. It is maravilloso. Anyway, so okay, I'm still waiting for the screen. You cannot see it. I'm the one seeing it, but you cannot see it because you don't have my eyes to see it. But I will allow you, to the power of technology, to also see it. Good. Okay, but in the meanwhile, let us look at the rule, the trapezoidal rule that we are going to code. Okay, let me do something that you really enjoy. When I would say have a happy maths weekend, then it will really be happy for you. You will not enjoy the weekend, but you will enjoy it, right? Okay, so let me do this. Let me share something with you. Even though people like Johannes came late, where is Johannesburg, or is Johannes something? Johannes window? I don't know. Anyway, recent, all this. Okay, it's fine. Because when I say Python, oh, some people are dizzy. Yeah, Python, oh, it's a nightmare. No, it shouldn't be. It shouldn't. Nada. It shouldn't. Okay, so this is what we did last time, and this is our rule, huh? This is our rule. Oh no. Oh. Yes, this one. Oh, this one. Oh, this one. Ooh. All right. Okay, this one. Even. Odd. Ooh. Okay, so this is the rule. Oh. Wow. So today is the first day of the month, the 1st of October. Ooh. Wow. Hey, you guys. You are blessed to be here on the first day. On the first day of the month. Hey. All right. Okay, so let me, you see now, what I'll do now is not witchcraft. Look, bam. Oh, guys, it's not witchcraft. Oh, so this is not witchcraft. Some of you will go to Bamboland and say, hey, I saw something there, something that I've never seen before. Those people, they will show us witchcraft. No, let me eat my mahangu. I'm happy with my mahangu. Yeah, you should be happy. Mango is nice, eh? Ooh. Mango, ooh. That thing, that mahango, ooh. Okay, so we say here that this is a composite trapezoidal, no, Simpson. Composite Simpson rule. Simpson. Simpson's rule. Hey. All right. Okay, anyway, this is not new, but this is a continuation. This is what? A continuation. This is not new. It is what? A continuation. So I will write here continuation. To say we continue. All right. Now, as I said, algorithm. Okay, now we are going to see how to program this, right? Programming of pseudocode or whatsoever. Programming pseudocode. This is like programming. I'm just giving you. I'm just preparing you for the coding. I obviously already coded, but at least for some of you who might not understand why I did this or why I did that, you see, and because also part-time student will be watching this, so I'm doing that for all of you. A pseudocode or whatsoever. Okay, Pseudocode. Pseudocode. Algorithm, pseudocode, programming. Call it whatever you want. You are free to call whatever you want. Nobody will take you. Nobody will sue you. You are free. At that time, you are like a father giving a name to the child, a mother giving a name to the child. Nobody will sue you because you decided that your child will be called Aaron Free. You see, nobody will sue you for that. It is your right. It is your human or your mother, your parental right. Even if you decide that your child will be called Vinduk. Nobody will sue you for that. All right. Okay, now what do you see here? Here you see that you have two sums. You have this first sum, you have this second sum, right? You have two sums, right? And then you have a product, you have another product here, and then you add this term. So the best way to do this, if you want to program this, we know already, we know. Maybe you don't know, but I know. Anyway, or some of us, we know that. If you want to sum, right? If you recall, yeah, that was in the first semester, numerical method 1, if you recall. I took a vector, and I told you that, okay, if you want to compute the sum of the entries of a vector, you define sum that you assign to 0, and then you take a while loop. In a while loop, right, a sum, because here you have the sum, and that is exactly, those are the building blocks. Remember, we did the sum and the product. Do you recall it? Okay, let me check to see those who recall, because if I, it's as if I'm alone. I don't want to be alone. Yeah, I don't want to be alone. Okay, if you recall, please raise your hand. There's a place there where you can raise your hand. If you go to where, there is, okay, there is okay, from the left, if you count the first menu, second menu, the third menu, you will see that there's a hand like this, and there's also somebody smiling there. A smiley, it's not even somebody, it's a picture. Okay, now if you put the cursor there, you will see a finger like this, you will see a heart, a beautiful heart like that. And you will see a hand like this, clapping. You will see somebody smiling, and you will see the hand like this. Okay, now, if you recall what we did first semester, where I gave you the pseudocode for adding, that is for the sum and for the product. Raise your hand. I want to see how many people here remember that. Camelo, so you don't even remember? Nobody, even Kashopi, you don't remember? Hey, what is going on here? Simeon, you two, you don't remember? Hey, Janice. Hey, what is going on here? Petros, Aaron, Frida. Huh? Okay, if you don't remember, raise your hand. I want to see. So even when I ask if you don't remember, raise your hand, nobody's raising his hand. Okay, I see one. At least he's honest. Who else does not remember? 2, 3, 4, 5. So the majority. There is another person there, I will not mention the name, who did not even raise a hand. When I ask if you remember or you don't remember, the person is okay. All right. Okay. So let me quickly remind you. It's good to be honest, because if I knew that you remember, I would have just proceeded. But since the majority you don't remember, let me do this. Okay. Now let's say you have a vector v. Okay. So here I will recall the sum. So here I'm recalling how to program the sum or the compute program. The sum of the entries of a vector. These are building blocks of programming. You have sum and product. You need to know how to program them. And you need to know how to evaluate a polynomial at a point. If you can do that, you already have a good foundation of a vector. So I will call that vector, let's say u, and the entries of u, obviously, u is u sub I, where I takes the value 1, 2, let's say n. So there are n entries, right? Now for this, what we do, the first step is to declare or define, define. In a program, but in Python, you don't declare variable because, anyway, I will not go into the detail. So let's say define or declare. N, that is the number of entries, right? And declare or define, and the UI, that is U1, U2 up to UN. You declare them or you define them off because you need to know them. When I say declare, it means that these are the data. You need to know the data, otherwise, what are you going to be computing? So you need to declare all of them. Obviously, the sum, this sum, you initialize it to 0. Of course, let's say declare whatsoever. So these are, okay, so that's the first step. And now, the next step, you initialize. You initialize sum to 0. And that is it. Now I can enter my for loop, right? So last step, loop. I loop the entries. Loop meaning that, okay, this is the loop for k, taking the values 1, 2 up to n. I do the following. So now to this sum, which initially is 0, I assign. So this is assignment in pseudocode. It means that sum is equal to. And now you say you take the value here, you put inside. That is assignment, right? I assign sum plus u sub I. And that is it, N4. So this is the end of the for loop. When I say N4, it's end of the for loop. So once I exit this for loop, sum has all the entries. So here, actually, so on exit, sum is equal to this. So in fact, I'm writing this mathematically, but that's just to tell you that in sum, this is what you have. Oh, I put I here I put K. They have to match, right? You should not make that mistake because I use K, so this should be K. Obviously, this is mathematically, but in the program, I will use a square bracket here for an array. But this is just pseudocode. All right, so this is what your sum will get, this sum. So you see how this is coded. So if I want to code something of this form, this is how I proceed. So I'm writing this for you to see. That is, I have a formula with something of this form. This is how my pseudocode should be. That's how I compute this sum that I store into sum, or whatsoever you put there, or else whatsoever is up to you. But this is the pseudocode. This is how you program it. Program it like this. But before doing this, you need to declare all these values. Even K, we could have said here declare K. Of course, this is general. Let's say, for instance, if you are using C programming language, you need to declare all the variables. But in Python, there's no need, you just use them. Some you need to assign, like the vector, you need to assign to 0, things like that. Okay, so that is the idea. So once you understand this, the code that I wrote the other day should not be a problem to you. Because we have two sums, you can see. Now, if I scroll up, you can see that this sum is similar to this one, to this term. And this second sum is also similar. The only difference here is the range of K. It's also similar to this. So you see that for that, because the range, you see that you have two different, the range here, these two ranges are different. So I can write two for loops, but I can still even write a single for loop, but I have to perform a test inside, right? In the code, I wrote two different for loops, right? First loop, second loop, but you can combine the two into a single loop. You can still do that. You can still do that. But if you do that, you have to test if, because for this second one, for the first sum here, you can see that K runs from 1 to n minus 1, whereas the second one runs from 1 to n. So you have to make sure that when you use a single for loop, you test inside to make sure that one of the sum inside will not exceed its range. So you can still do that. The code that I wrote last time is not unique. That's why you need to learn programming, so that you can come up with your own idea, or which is even more efficient, right? But you need to know the basics so that you can use your brain to come up with something that is different. That's what you call innovation. Innovation comes, somebody sit like this, he has an imagination that is different from what people have been doing. You just bring a touch, you innovate. That is it. So the basics should be there. You need to know the basics. So once you know how to write a sum of something, now it's up to you to manipulate, right? But the basic, the fundamentals or the building blocks are these things. How to compute a sum, how to test those are the programming constructs. If you take any programming book and read through, you will see that you'll be taught how to program or algorithmic, because you have algorithmic books and you have programming books. They are different. Algorithmic are the steps to program something, but in algorithmic, you don't actually need to know the programming language. It's just the structure or the logic to solve a problem. That is the algorithm, right? Algorithm is the logic. If I want to count, maybe, let's say, for instance, I want to list all the prime number from 1 to 100, for instance. That is algorithmic, right? You need to write an algorithm or a sequence of logical expression that will select. So you run 1, 2, 3, 4 up to 100 in a loop, but inside you'll be testing, right, some conditions. So that's algorithm. Now, if you want to program, You first write the algorithm, and now programming is to code. It's like translating the pseudocode into a particular programming language. So when you talk about programming, there are two stages. You have the algorithmic step, or the pseudocode, where you write the logic to solve the problem. Because you cannot just go straight and start coding. No. You need to write the logic and make sure that that logic works properly. You can even run it manually with a small set of data. You make sure that the logic works with a small set of data. Now, when you program, you test that small set of data to make sure that your program is functional, that it returns the expected result. Once that is done, now you can increase the size and scale up your program. Scaling up means that you can increase the size, right? Scaling, it's about the size. Okay, now with this being said, let's go back now to our code, because now we are done with this, right? Now, let's go to the code. I can go to the code now. I can go to the code. Okay, let me check. I see some titles here. What was the name that I gave to that program? I want to find out. The code of yesterday, I gave a name, because I can see some program here. But I don't see that name. Which name did I give? Simpson, yeah, I think it was something about Simpson. But here, I don't see any Simpson. Okay, let me quickly check the names. I see bisect. Okay, Composite Simpson. Good, it's there. 2 days ago. Great, so it's there. Oh, you should rejoice, guys. You should rejoice. Rejoice, man. Great. Good. It's there. Okay, now let me share that with you so that I will not cry. No, I didn't share that with us. You start crying like a child. Okay. Composite Simpson. Great. Okay, so this is the code. Okay, so I mentioned that there are two. So recall the formula. Recall the formula. Now, we have the formula. So recall, bear that formula in mind. You see that this S is like our Simpson rule, right? This is the first term, which is h by 3 into f of a plus f of b plus. Now, this is for even terms, right? The factor is 2h by 3 into, remember the sum, that sum, where k runs from 1 to n minus 1. F of x sub 2k is this one, the even. Now, for the odd, here, the factor is k by 8, 4h by 3 into some k running from 1 to n, f of 2k minus 1, if you recall. That's what you have here. Good. Now, if you take this part, these two, you see that this first sum is for the even terms, we can see here, and the second one, SO, is for the odd terms. You see, and you can see that this structure is exactly the same as what we use with sum. This is like S here is like sum, and here, what do we want to sum up? Those are the entries, right? We want to sum f of x sub k, sub 2k or sub 2k minus 1. Those are the entries. Those who play the role of our u sub I or sub k, depending on what you are using. Now you can see that this is exactly the terms here. Our u sub k for the first is replaced by f of x sub 2k, and here is replaced by f of x sub 2k minus 1. But now we adapt it to the syntax of Python, because each programming language has its syntax. That's why you need to know the syntax of the programming language you are intending to use. So for this particular case, this is exactly what we have. So I hope that with this explanation, you will understand better. And also for the for loop, remember that in Python you use range, but the range, the last entry here is not attained. You don't reach it, right? You don't attain the first, the last, this n, for instance. So when you say for here, the last value that k would take would be n minus 1. So this n is like the boundary that you don't reach. It's the boundary. Similarly here, n plus 1. So it's up to you to play around. So when you program, there's little tricks that you need to check for yourself. Because I myself, when I program, I didn't know that this would be n plus 1. It's when I program that I check. I say, oh, it has to go up to this. So you check first. That's programming, you check. It's not something that you write in one go. You write, you test, you see what is wrong. That's why it requires patience. You have to be patient when you program. And this is a learning curve you have to go through. Another thing also is x, f of x. Remember that we need x, and x in the formula in the note, we said that x sub k is what? Is a, that is the first limit of integration, because we want to take equally spaced, plus k h, where h is b minus a by n, or 2n in the case of Simpson. So so this is how you write it if you use linspace. You can use linspace to do that if you want to. So I will encourage you to download the video that I recorded yesterday, because I explained all this in that video. Right. So we have 2 minutes to go. So you can see that when we run this code, we obtain the exact result, right? Let me rerun it. Let me rerun that for you. Okay, you can see that here we have 0. Okay, now if I run it all over, you see that this file will be changed into 1. You see, it's busy running. You have star there into input. You can see that you have star here where the cursor is. You see, it has been changed to 1, and this is the result. Okay, now let me even change the value of, we can see that here our A is equal to 1, and B is equal to 6. You can see from here, 1, 6. Or still, I can change the number of sub-interval, because I chose the number of sub-interval to be 10, right? Now, what if I take the number of sub-interval to be, let's say 100? Okay, if I take 100, you will see that this value here, that was returned. This is the value. Okay, let's look the term after. Okay, let's look at the first 6 terms. 1, 2, 3, 4, 5, 6, 7. You can see that the last term will be 4 here, 4, 9. Now, if I reduce, let's see what 4, 9 will become. That is 1, 2, 3, 4, 5, 6. After 6 digits, 1, 2, 3, 4, 5, 6 is 5. And after 5, you have 4, 9. So let's say 5, 4, 9. Let's see how this 5, 4, 9 will be changed to. So here I say 100. Instead of 10, let me take 100, and this is 549. Let's see how this 549 will be changed. So let me rerun this. You see that it has changed completely. You see that we have a complete different result here. What was the previous value? Wait. What was happened? What changed? Wait. Something. What have I changed here? I changed n. I changed. No. Wait. That result is very bad. Let me see that again. You see, this is 8 something. But why is it changing drastically like that? Something is not right. It's supposed to still be 8, huh? Okay, let me put 20 and see. So it means that something is not. It's 5. Something is not 1, 2, 3, 1, 2, 3. Oh, no, sorry. Yeah, I see. Okay, so if I have to change the 2, right? Of course, they are not related per se. So remember that if capital N is 10, the lowercase n is half that number. So if I put 100 here, this should be 50, right? Half of that. Of course, that's the way I program it. But okay, now let's run it. Okay, now you can see we still have our 4. What is that? Okay, it's 8 point. You see that these digits have changed. You see, they have changed completely. It's no longer the same. We had it was 149 from the feet. 1, 2, 3, 4, 5. You see that it has changed completely. We have a completely different result here. We have a completely different result. Okay, it's completely different. And this one is becoming more and more accurate, right? Now, if I take, yeah, this is more accurate compared to the previous result because we have increased the number of points. So when h becomes smaller, the method has to converge. Okay, I think we'll stop here for today. You have the code. Please go through, run the code, and try to see what is going on. Thank you for your kind attention. God bless you. Have a happy programming weekend. Take the time to go through Python. Please make sure that you improve your programming skill. You will not regret. I can assure you that if you do so, tomorrow you will look for me to give me a big bamboo chicken, the big one, the biggest bamboo chicken raised in Bamboo land. God bless you. Bye-bye.